Hi there, learners! Welcome back to Science with Teacher Tina. How are you? Are you feeling good today?
Yes.
Awesome! To start today's lesson, these are the tips for you to remember to keep you healthy while indulging some screen time.
Sit properly so you are well supported. Change your position regularly. Make sure you have taken your meal to keep you energized. Do some stretch breaks from time to time. Now you're ready to begin.
For today's exploration, you will learn about the electromagnetic spectrum. Scientists have found that many types of waves can be arranged together like notes on a piano keyboard to form a scale. I am excited to explore these concepts with you today. What do you need to know about our electromagnetic spectrum? So for our objectives, we need to know more about the names of the types of waves and the order that they are arranged in, the uses of each type of wave, how each type of wave is made, and the dangers of each type of wave. You have learned about waves during your grade 7 science class. Let's recall some important terms about it. So, let's play Guess the Jumbled Letters. Your task is to rearrange the jumbled letters to form the term being described. Let's start.
Now here are the answers.
How many words do you remember well? Oh, you got it all right! Perfect! You have probably seen some waves, but have you created one? Let's try to make some waves. Draw the wave you made on a separate sheet of paper.
Get a rope of any kind and tie one end of it to a fixed sturdy object near you. Now strengthen on the rope and hold the other end of it. Start moving your hands up and down. Observe what happens to the rope. Were you able to make a wave? Now try to make a wave again, but move your hands slowly and observe what happens. This time, make a wave while moving your hands fast.
When you move your hands up and down while holding one end of the rope, you create waves in the rope. The waves you created may look different depending on how fast you move your hand. Similarly, if you move an electrically charged object back and forth in an empty space, you'll create electromagnetic waves in space. But what is an electromagnetic wave and an EM spectrum?
The electromagnetic spectrum is the complete spectrum of all forms of light. An electromagnetic wave consists of electric and magnetic fields which vibrate, thus making waves.
All parts of the electromagnetic spectrum travel at the same speed. Therefore, wavelength and frequency have an indirect relationship. Indirect relationship. This means that as one characteristic increases, the other decreases. In other words, a wavelength increases, the frequency decreases. Take note of that. So, the relationship between the wavelength and the frequency, where the shorter wavelength have a high frequency and the longer wavelengths have a low frequency. Meanwhile, for the frequency and the energy, if we say we have high frequency waves, they have also high energy. And if they have low frequency waves, they have low energy. Okay? The electromagnetic spectrum consists of radio waves, microwaves, infrared waves, visible light waves, ultraviolet waves, X-ray waves, and gamma waves. All of these different types of electromagnetic waves in the electromagnetic spectrum are very easily to be remembered using the phrase red monkeys in vans use X-ray glasses. Again, red monkeys in vans use X-ray glasses, so that it will be easily remembered the different types of electromagnetic waves in the electromagnetic spectrum. Now, let's strengthen your concepts regarding the different EM waves. And as you move along, you will discover some characteristics of EM waves. So, are you ready to ride the waves? Great! Let's go!
Application of electromagnetic waves. The full range of electromagnetic waves, arranged orderly in their wavelengths and frequencies, is called the electromagnetic spectrum. The electromagnetic spectrum is the full range of electromagnetic waves, ranges from gamma rays, which have shortest wavelength, to radio waves, with the longest wavelength. Radio waves often used for radio communication and television transmission. Electric oscillators and transmitting antenna are the source of radio waves. Microwaves electromagnetic spectrum used in radar system, telecommunicate via satellites, cellular phone service, and microwave ovens for cooking. We can find infrared radiation in remote controls, infrared photographs and infrared scan on a patient for diagnosing cancer. Visible light enables the human eye to see objects, enables photographs to be taken, and causes the photosynthesis in green plants. Light in optical fibers is used in medicine and telecommunications. Laser light is widely used in medicine, engineering and telecommunications. Ultraviolet radiation produces vitamin D in the skin. Overexposure can cause skin cancer and damage to the retina. It also causes fluorescent effects used for detecting forged notes. Radiographs or X-ray pictures as a diagnostic tool in medicine and dentistry. X-rays used to expose hidden flaws and cracks in metal parts, and to inspect the insides of electrical appliances. Gamma rays are used to kill cancerous cells, sterilize hospital equipment, and also to kill bacteria in fruit and foods in order to preserve them.
Radiation exists all around us, from both natural and man-made sources. It comes in two forms: ionizing and non-ionizing radiation. Ionizing radiation is a form of energy that acts by removing electrons from atoms and molecules of materials that include air, water, and living tissues. On the other hand, non-ionizing radiation is a form of low-energy radiation that does not have enough energy to remove an electron from an atom or molecule. Most types of non-ionizing radiation have not been found to cause cancer. The dividing line between non-ionizing and ionizing radiation occurs in the ultraviolet part of the electromagnetic spectrum. Radiation in the ultraviolet band and at lower energies is called non-ionizing radiation, while at the higher energies, to the right of the ultraviolet band, is called ionizing radiation. Ultraviolet radiation comes from the sun, welding, black lights, and UV lasers. The sun emits UVA, UVB, and UVC rays. UVC rays are absorbed by the ozone layer and never actually reach the Earth. Both UVA and UVB light are important for humans in the production of vitamin D. However, the effects of overexposure to ultraviolet rays can be negative and can be immediate or delayed. Sunburn, skin cancer, and cataracts develop over time with excessive exposure. The visible light portion of the electromagnetic spectrum can be seen by humans, animals, and other organisms. This type of light consists of 7 colors: red, orange, yellow, green, blue, indigo, and violet. When all the colors are present at one time, the light is white. Overexposure to visible light can damage both the eyes and skin. Infrared is used in thermal scanners, remote controls, and night vision goggles. The human eye can't see most of the infrared spectrum. About half of the total energy the sun gives off is in the form of infrared radiation, which we feel as heat. In large amounts, this type of radiation can damage the eyes and even cause blindness. Infrared radiation from the sun is normally absorbed by the Earth's surface and the clouds, then released as heat into the atmosphere. When the atmosphere has a lot of water vapor, along with nitrogen, sulfur, and fluorocarbons, the infrared radiation gets trapped and causes the atmospheric temperature to rise. This is called the greenhouse effect. Temperature increases cause changes in the weather patterns on Earth and lead to climate change. A microwave oven works because microwaves excite the water molecules in food and cause them to vibrate, generating heat and cooking the food. Atoms and molecules can also emit and absorb microwave radiation. Overexposure to microwave radiation can cause cataracts and skin burns. AM and FM radio broadcasts, Wi-Fi signals, cell phones, and television use radio frequency waves. Exposure to electromagnetic fields in this frequency range can warm up exposed parts of the body because these absorb the radio wave and convert these into heat. The frequency level determines the depth of penetration into the body. For example, using a cell phone causes the ear and/or head to get warm. Lasers aren't a form of non-ionizing radiation, but they are made from it. The word laser is an acronym for Light Amplification by Stimulated Emission of Radiation. Lasers stimulate atoms and molecules and cause them to produce light and concentrate it into a beam of radiation. Lasers can be made from visible light, ultraviolet, and infrared waves. Store checkout scanners, laser pointers, and laser printers all use lasers. When not used properly, lasers burn and cause severe damage to our body, especially in the eye. The narrow beam of light concentrates the effects on the retina, causing blind spots. Ionizing radiation is a type of energy released by atoms in the form of electromagnetic waves or particles. Ionizing radiation takes a few forms: alpha, beta, and neutron particles, and gamma and X-rays. Ionizing radiation has many beneficial applications, including uses in medicine, industry, agriculture, and research. As the use of ionizing radiation increases, so does the potential for health hazards if not properly used or contained. Alpha radiation occurs when an atom undergoes radioactive decay, giving off a particle called an alpha particle. Alpha particles lack the energy to penetrate even the outer layer of skin, so exposure to the outside of the body is not a major concern. Inside the body, however, they can be very harmful. If alpha emitters are inhaled, swallowed, or get into the body through a cut, the alpha particles can damage sensitive living tissue. Beta radiation takes the form of either an electron or a positron, a particle with the size and mass of an electron, but with a positive charge, being emitted from an atom. It can be stopped by a thick piece of plastic or even a stack of paper. It can penetrate skin a few centimeters, posing somewhat of an external health risk. However, the main threat is still primarily from internal emission from ingested material. Gamma radiation, unlike alpha or beta, does not consist of any particles. Instead, it consists of a photon of energy being emitted from an unstable nucleus. Gamma waves can be stopped by a thick or dense enough layer of material, with high atomic number materials such as lead or depleted uranium being the most effective form of shielding. The extremely high energy of gamma rays allow them to penetrate just about anything. They can even pass through bones. This makes gamma rays very dangerous. They can destroy living cells, produce gene mutations, and cause cancer. Ironically, the deadly effects of gamma rays can be used to treat cancer. In this type of treatment, a medical device sends out focused gamma rays that target cancerous cells. The gamma rays kill the cells and destroy the cancer. The use of X-rays and radioactive materials in science, medicine, and industry led to the documentation of radiation burns. Radiation exposure, although helpful for the diagnosis and treatment of disease, might also be harmful, and protective measures were taken to limit exposure. All X-rays are dangerous because they can damage healthy living cells of the body. This is the reason why frequent exposure to X-rays should be avoided. X-rays can cause mutations in our DNA and therefore might lead to cancer later in life. For this reason, X-rays are classified as a carcinogen by the World Health Organization. While X-rays are linked to a slightly increased risk of cancer, there is an extremely low risk of short-term side effects. However, X-rays provide such a low dose of radiation that they are not believed to cause any immediate health problems. Lastly, neutron radiation consists of a free neutron, usually emitted as a result of spontaneous or induced nuclear fission. They can, however, be effectively stopped if blocked by a hydrogen-rich material, such as concrete or water. In living tissue, neutrons have a relatively high biological effectiveness and are roughly 10 times more dangerous at causing biological damage compared to gamma or beta radiation of equivalent energy exposure. These neutrons can either cause cells to change in their functionality or to completely stop replicating, causing damage to the body over time. Neutrons are particularly damaging to soft tissues, like the cornea of the eye. Here's a quick recap. Electromagnetic waves vary in their wavelengths and frequencies. Higher frequency waves have more energy. Of all electromagnetic waves, gamma rays have the shortest wavelengths and highest frequencies. Because of their very high frequencies, gamma rays have more energy than any other electromagnetic wave. Radiation exists all around us, from both natural and man-made sources, and comes in two forms: ionizing and non-ionizing radiation.
Now it's time to think and apply what you know. Kindly click this link and you can take your short quiz. Click, click, click.
Well done, learners! We will see each other again in our next episode. That ends our lesson for today. Always remember, learn with confidence, because together we learn, inspire, and grow. Bye-bye!